Welcome you all to the lecture series. In this lecture we are going to see about MOST protocol, which is said to be media oriented system transport. First of all, going before to MOST, we need to know what are the various types of medias that are being used in automobiles. Starting from radio, now we are using USB, videos, etc., which are said to be the media oriented. All these are being controlled with the help of MOST. Okay, why there is a need of networking here? For these devices, what is the need of networking means, while the call is coming, call is ringing means in our mobile phone, at the time what happens, automatically the radio or the songs which are played with the help of USBs are being muted, and the person is able to take the call and talk without any disturbances. And we used to share the display for radio, navigation, rear view cameras, etc. that are being done by the help of networking only. And traffic information transmitted to the radio can be used for efficient navigation also. So for this purpose only, these devices need networking. Why do media oriented devices need a new networking protocol? In order to have a safe and secured thing. And we all know that infotainment is said to be information and entertainment. This application requires fast, short delay networking with communication bandwidth availability. So for this purpose only, we need a new networking protocol. So if there is no new networking protocol and we are using some other protocols, means automatically what will happen, it will lead to collision, or we will be losing some of the data, or there will be some unwanted disturbances. So for that purpose only, we are going for MOST oriented system transports. Okay, and what is the bandwidth requirements that we need to know? It requires a high data rate. For an example, we can take an audio signal which is of 44.100 kHz into 16-bit quantization, that is the CD quality, and 2-channel, that is stereo quality. Required data rate is 1.4 megabytes per second. It cannot be achieved by CAN, so we are going for MOST. And if you are streaming the data which is audio or video, as well as a packet data, that is map data for navigation, need larger amount of bandwidth with short delay, so it cannot be obtained by CAN. For this we are going for MOST. Okay, now let's take a look on the general overview of MOST, that is media oriented system transport. MOST Corporation founded it in the year of 1998. The corporation is combination of various companies and used by 16 car makers, and more than 70 suppliers are there. Mainly the first application was done in BMW Series 7, Audi A6, Audi 8, Q7, and transmission of streaming data, that is entertainment system or internet configurations. It is based on D2B. What do you mean by D2 means? D2 refers domestic digital signal, and it was developed by Daimler. Standardization of all 7 ISO per OSI protocol layers. So all the 7 layers are being used. You can see here. Normally physical layer, data link layer, network service layer 1, that is the basic one, and network service layer 2, that is the application circuit. And in the function, we used to have the function block, 3 different function blocks. So this part is set to be the stream service, and this part is mainly used for sending and receiving the data and converting the data as per the requirement. So it is using the ISO OSI model, all the 7 layers. Now let's take a look on what are the different types of MOST. We are having MOST 25, MOST 50, MOST 150. The different types are based on the data rate and based on the channels. Okay, and it is also been differentiated with the help of transmission. First of all, in MOS 25, optical transmission over POF technique was used, that is the plastic optical fiber. After that, in MOS 50 it was electrical transmission, and in MOS 150 it was enhancement of 100 bus T Ethernet. So the types are being splitted into 3 based on the channels, data rate, and based on the transmission. Okay, now let's take a look on the topology. So here we are going to use a logical ring with n nodes. So physically there are n-1 point-to-point connections, that is each node is going to have the connections. It was being implemented by the physical ring or the star network. Normally what used to happen, if the node is inactive, automatically the data will be bypassed. Active nodes will be receiving the data, add data or transmit the data, and resulting the data stream to the successor, that is the next node. Okay, now let's take a look on the functions. As it has been indicated, it is connected in logical ring. So here we are going to have a master which is going to generate the timing, am I right? And after that you are going to have others as the slave. Each and every node will be having the phase lock loop PLL. Okay, this is said to be the timing slave and the timing master. How the process is going to take place here? Timing master periodically generates the frames. Okay, so here the frame is going to be generated, and one after other each and every slave is going to receive the signal. So each and every slave is going to receive the signal, and based on the signal it is going to synchronize itself, and it is going to phrase the frames, and it is going to process the desired information, that is whether it is going to control or whether it is going to receive the data or going to send the data, and it is going to add the information based on the free slots that are present in the frames, and it is also going to transmit the frame to the successor, that is the next node. Am I right? When the frame is eventually returned to the timer master, what happens? It synchronizes itself and it is going to generate the next frame in accordance to the frame rate, based on the frame rate. So this is the process that is going to take place. And what do you mean by synchronization here? That is the main thing. The time master sends the most frame to the successor in a logical ring within a network wide consisting frame rate periodicity. What is the frame rate? For DVD it is 48 kilohertz, and for CD it is going to be 44.100 kilohertz. And if the time slave works with different sampling rate, the slave has to convert the data according to the system frame. So you would have seen in vehicles the media control. We used to have the media control. In that we used to change the channel. If you want to have radio used to play. When you are changing the data to CD, automatically CD used to take the control. So based upon the thing which we need, automatically what happens? The slave works with a different sampling, and the slave has to convert the data according to the system frame rate. So based on the frame rate, automatically the changeover takes place. So every slave synchronizes with the frame. How the synchronization is being take place is phase lock looped. As we have seen before, each and every slave will be having the PLL in order to have the synchronization between the data. Okay, so time master often integrated in HMI of the infotainment system, as we used to see in our vehicles. Now let's take a look on the various blocks of the functions. Am I right? Here you can see the function block provides what are the various functions. Normally the properties, specification of the specific device characteristics, that is whether current, frequency of radio tuner, and it is going to tell what is the methods, that is radio station scanning. This is said to be the function block function. Okay, and what is the function of the controller application? It is going to read and modify the priorities of the slave, a register for particular events, then call the message of the slave. That is, if you need this station, that station are 105.5, 103.5, 93.5. Based on the station, it is going to read the data and it is going to set that one, register the particular. So first thing is it is going to read, next going to register, then it is going to call the message of the slave. So how the function used to take place here. Okay, now in function blocks we used to have the net block, power master and network master. What is the function of a net block? It is going to manage all the blocks of the devices, manage of all the addresses, that is the physical address, logical address and the group address. Okay, what is the work of the power master? Mainly it is used for startup and shutdown of the network. What is the use of network master? Startup of the system, okay, and monitor the network system status, that is system means the status of the network, and the total administration, that is list of all the function blocks within the network. What does each and every function block used to do? And next we need to know about the connection master. It is going to set up and disconnection of synchronous channel. When the call used to come, automatically what happens? The media used to mute and automatically the call used to connect with the person. Am I right? And we used to talk. So this setup and disconnection used to be done by the connection master. And at last we used to see about the application and specific function blocks. Normally start playing, mute, etc. It is the application specific function block. In addressing there are different types. What is functional addressing? That is, every node has a unique address according to its position, and logical addressing, that is arbitrary addressing, that is address assignment controlled by the master, that is said to be the logical addressing, and broadcast addressing of all nodes in logical ring, because after each and every node this process is going to go to the next node till it reaches the master. Am I right? So the last one is group address, that is addressing of logical groups. Broadcast means logical rings, the group address means logical groups. So how the IDs are going to be given? Based on the device ID, functional block ID, instance of the functional block, then function to use, then operation, then length and the data. Here the bit size is being given and the description of each and every IDs. Okay, here you can see the most 25 protocols frame. It is going to have 16 frames, that is said to be the one block. In that we are going to have the synchronized data area, asynchronous data area and a control channel also. So it is the combination of all the three. Now let's take a look on the control channel. What is the need of the control channel? Mainly it is used for transportation of commands, status and diagnostic informations. Normally the control channel only used to tell which channel we are going to stream the data. That is, streaming data channel the sender and the receiver is going to use. So basically it is being told by the control channel only. Once the data connection is established, the data can flow continuously and no further addressing and processing of packet label is required. Normally the features of this control channel are low data rate, error detection by CRC, automatic retry after error, and in order to prevent the high controlled overhead in frames, control information is distributed over 16 frames and prioritization by arbitration technique. We would have seen about arbitration in CAN. Based on that, here the process is going to take place. Okay, now let's take a look on the synchronization channel. Normally, transportation of streaming data, that is audio or video, it is going to be in continuous high data rate, and up to 15 stereo connections with 16-bit quantization, or up to 60 mono connections with 8-bit quantization are going to be used. There is no need of addressing, channel source and sync defined during channel setup. So there is no need of this thing, and no error detection is going to be there, and point to multi-point connection is going to be there, and setup and shutdown of connection is done on the control channel. It is not going to be done in the synchronization channel. And streaming data can be calculated, that is net data rate is equal to boundary descriptor into 4 into 8 bits into sampling rate. That tells about the streaming data rate of the network. Okay, now let's take a look on the asynchronous channel. Okay, the transportation of spontaneous packet based data, that is example map updates, internet, everything, it is going to be done in an instant, which is going to come under the asynchronous channel. And temporary high data rate, that is for example graphics, picture formats, navigation maps, that are going to be the temporary high data rates. And error detection is going to be done by the CRC and positive and negative acknowledgements, and maximum of 58 bytes are going to be used, and prioritization is done with the help of arbitration. I hope you are clear with most protocol. It is somewhat different from CAN, and mainly it depends upon the 3 channels, that is asynchronous channel, synchronous channel and the control channel. So based on this only the various process used to take place. Each and every channel used to do various things.